In this video, we're going to be tackling the LeetCode question, max consecutive ones. And we're going to start at the very bottom and we're going to work our way up to the top. Piece by piece, we are going to build this algorithm. So in 99% of cases, LeetCode algorithms have two things and only two things. They have state and they have iteration. But what exactly is state? You may not be familiar with what state is. State is pretty much a fancy word for a variable, but it's a variable with one specific purpose. It's there to store information to inevitably obtain the result of the algorithm. And what result are we trying to obtain with this algorithm? We're trying to obtain the max consecutive ones. So naturally, what we're going to do is we're going to store the max in a form of state. We got off easy in this example. We're going to have at most two pieces of state. We'll also have a count as well too. I'll explain what count does later on in the video. But whenever you need to create an algorithm, whenever you need to create state, just look at it almost as like ingredients in a meal that you're about to create. What type of ingredients, what type of pieces of food do you need to come out with the product that you need? So enough theory. Let's go ahead and let's piece this thing together. We know that we're going to need state. We know that we're going to need iteration. Let's go ahead and start off with our state. We're going to need our max and we're going to need our count. And we're going to need our max and our count, number one, because this would be very difficult to keep track of if we didn't store as state. I'm sure there's another way that we could do it, but also that's what the algorithm needs to return. That is the recipe, so to speak, that we are trying to make. So now that we have our state declared, what we can do now is we can begin our iteration. And when we iterate, the only thing that we have to do is we have to assign a for loop. And this little red box right here will indicate a for loop. And we're going to use this for loop to iterate from the front to the back, one by one, through each element. As we iterate from front to back, going through each element, we need to ask ourselves a very important question. What exactly are we looking for? We're looking for something. We're looking for a 1. And once we find a 1, we need to keep track of each consecutive sequence. How exactly are we going to do that? Well, let's just go step by step. We're going to land on our first element. We need to increment our count, and we also need to update our max. We have indeed found a new max, and we've also found a 1, so we need to increment our count. But why exactly do we have max and count? Couldn't we just get by with max? Well, we have a max because there's two different sequences, and we need to figure out which one is the max. And we can't just skip the first one because this algorithm doesn't know. We have to go through every single element. So what's going to happen is we're going to go to our next element, which is indeed a 1. We're going to increment our count, and we're also going to reset our max. Then we're going to reach 0. And this is the reason that we have a count. If we reach a 0, we've broken the sequence. We're going to go ahead and reset the count to 0. We're not going to change our max because we no longer have a max. Then this process is going to repeat. We're going to go to our 1, going to increment our count. We're not over 2, so our max isn't going to update. Then we're going to do the same exact thing. We're going to increment our count, so our count's going to become 2, and our max is 2, so max is not going to be updated. Last and final element, count is going to be incremented to 3, and our new max is now going to equal 3. And that is the whole entire idea behind the algorithm. So let's go code it in IntelliJ. So the first thing that we're going to do is we're going to create a new Java class, and I'm going to call this solution. Within the solution class, we will house our method. This method is going to return an integer of the number of max consecutive ones. And we're going to name our function, or our method, I should say, max consecutive ones. And it's going to take in an integer array called nums. So remember, every single algorithm needs two things. We need our states, and we're going to go ahead declare our state. We're going to have our max and our count. We can declare both of them as 0, which is simple enough. Then what we're going to do is we're going to go ahead and create our iteration. Now we could use a whole entire fully formed for loop just like this, but it's easier in this case just to use a for each. And what a for each looks like is this. It's basically a more syntax friendly version of a regular for loop. So what we're going to do is every single time we come across a num in our array that is equal to 1, what we're going to do is we're going to increment our count. We're going to go count plus 1. And if we don't find a 1, what we're going to do is we're going to reset the count. We're going to reset the count back to 0. Each time we add to our count, we also need to check if this is the maximum. There's many ways that we could do this. We could check with an if statement to see if it's the max, but in this case, and in most LeetCode questions, it's easier just to use math.max, and what math.max is going to do is compare those. And that's a very common pattern, just to use math.max. Then what we're going to do is, you guessed it, we're going to return our max. And that's pretty simple. So let's go ahead, let's copy this. I'm going to get out of full screen mode. We're going to toss this in LeetCode, see what we get. So I'm inside of LeetCode right now. And the first thing I'm going to do is just put my code in the text editor here. Let's go ahead and run our test. Test pass. Let's hit that submit button, see our time complexity. Time complexity is linear, and our space complexity is constant. Congratulations, we have passed the interview. Hope that you guys enjoyed this. If you did, smash that like button, smash that subscribe button, and as always, thank you for watching.